Hello, my calculus people. Hopefully you're enjoying my little word problems, even if they sometimes theoretically harm things. But a couple things on this. I wanted to help with the weird part of the back side. The front is pretty much like my notes from 3.2a. And I did an answer key for the video. So we got a question about penguin flying with a crazy question. And yes, answer the moral of the story. You know, you can make up a good moral to that story. And then shooting an arrow straight up in the air, which I must say you shouldn't do. But all these are pretty straightforward. When you get to number 4, it's different because number 4 is a question. First of all, it has Rutherford the monkey, which may become Rutherford the super monkey in the future. So what's weird about number 4 is he's being shot at an angle. And being shot at an angle, you do not get to use that initial velocity. So I'm going to give you an example problem that is similar, but not the same. So you have to change some stuff. The other thing is it asks a question about horizontal distance. And if it asks a question about horizontal distance, that uses a totally different formula that I did talk about in class, but we haven't used it in a while. When I was telling that long story about ringing a bell. Does that story ring a bell? All right, so let's look at what happens when you shoot something at an angle. So for instance, if I launched a projectile, let's say it was an arrow, right? So we had an arrow. Ooh. Arrow. So we're releasing this arrow. Let's say that it shoots at an angle of 30 degrees at an initial velocity, and you can find the initial velocity of bow and arrows, depending if you're strong enough to pull it back all the way. So it launches at an initial velocity of, let's say, 50 feet per second. I don't even know if that's good or not. Sounds a little slow, but let's go with it. All right, so the problem with this is, let's say you shot it from, here we go. We're got our arms here. All right, boom. Okay, so we're shooting that from a height of, that looks like about 4 feet in the air, right? It's a height of 4 feet, and we can write our equation from this, from an initial height of 4 feet. So our original equation normally goes like this. H of t equals negative 16 t squared plus VO t, that's initial velocity, plus HO, which is your initial height. So far, I can do the negative 16 t squared, and I can do the starting at 4 feet high. What I can't do is fill in this blank right here, because you would be wrong if you put a 50 in there. It is not shooting at 50 feet per second straight up in the air. It's actually shooting at 50 feet per second at a 30-degree angle. So what you have to do, if you ever have any projectile that's shot at an angle, you have to break it up into its 2 component parts. So when you see a 50 feet per second at an angle of 30 degrees, part of that arrow could be just pushing sideways, and part of the force of the arrow is pushing up. So you can actually split this diagonal force of 50 into how much of that 50 feet per second is going up and how much of that 50 feet per second is going sideways. Well, this is your velocity vertical, and this is your velocity horizontal. The good news is it's not really hard to figure out, and all you need is a little scientific calculator. So, you know, just a TI-30 will do it. If you have a better one, then use a better one. But you can always split an angled force by doing trig. And if you remember good old SOHCAHTOA, since sine is opposite over hypotenuse, you're going to use sine to find the vertical every time you have a normal problem where you're shooting something kind of in the air. Okay? So if you ever want to find the vertical part of a diagonal shot, you always take the angled part in feet per second times sine of the angle you shot it at. So that will find my vertical component. Now, would you expect it to be moving upwards at 50, at greater than 50, or at less than 50? I mean, even if I looked at this picture, if I looked at just the vertical part and I'm shooting it at a pretty low angle of 30 degrees, I'm wasting most of my power going sideways, right? If you were shooting at like 88 degrees, you'd be using most of it for vertical. But I would imagine that the horizontal should end up with a bigger answer than the vertical, since it's only a little 30-degree angle. Even look at these triangle arrows I drew. That's a shorter arrow than this one. And both of them are shorter than a diagonal. So I would expect the force on the diagonal to be the most, because that's where you're actually releasing the arrow. And then it's split up amongst here. Now don't think it's going to add up to 50, because it's not. It's not how trig works. It's also Pythagorean Theorem. So if I want to find out, I do 50 sine of 30. Now if you're using a graphing calculator, try this out. And if you don't get 20, oh, that came out nicely. If you don't get 25 feet per second, then you probably are in radians and not degrees. So double check your mode and see if you're in radians or degrees. I can do the horizontal part by taking 50 times cosine, because it's adjacent of hypotenuse, of 30 degrees. And I should get a number bigger than 25, but smaller than 50 if I just go by eyeballing the arrows. So 50 cosine of 30 degrees is 43.3. So if you look at that, most of my speed is being used sideways, which makes sense because 30-degree angle is pretty close to horizontal, right? And some of it's being used upwards. Okay, notice these don't add up to 50. I bet if you did Pythagorean Theorem, they would. Oh, bells. Okay, so which one do I use in this formula? Well, you use the one that means vertical, because height, this is your gravity, so we're just talking about the height of the arrow with this equation. So I would throw the 25 in here, and then I can find the velocity equation. Remember, it's just the derivative of this guy. And I can find acceleration of this guy. Now keep in mind, now that we're using motion in two directions, I'm going to use the other answer for something else. But these are your three equations, and they all deal with vertical velocity, vertical height, and vertical acceleration. There's one other equation you can do with this, and that uses this. And what is that? That's just how far horizontally your arrow flies. So if this is all the equations for vertical, then you get a really easy equation for horizontal. The horizontal equation is just distance equals rate times time. So I'm going to put a d with a horizontal equals rate horizontal times time. Time is still time, so don't worry about that. So distance horizontal equals 43.3 feet per second times time. Now you can answer all sorts of questions about it. This is your other equation. I can answer, when does the arrow hit the ground? Now, this is the hard part. When does the arrow hit the ground would be when my height is 0, right? So I just do this, 16t squared plus 25t plus 4. And you do Pythagorean theorem on that, not Pythagorean, quadratic formula on this. And you get two answers. Usually one of them is negative, so you throw it out. And the other one's positive, so it's actually the time it takes the arrow to hit the ground. If I asked a question like, when does it reach its highest height? Well, you know when it reaches its highest height? It reaches its highest height when its vertical velocity is 0. Because think about it. Your arrow is going to go up, 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 and then down, down, down. This is an exaggerated one, but even if you shoot it at a low angle, when you get to the very top, its vertical part goes from being up, up, up to down, down, down. It's getting faster on the way down, slower on the way up. At the very, very top, your velocity, your vertical velocity is 0. So you could set, if you wanted to know when it hits ground, you use this equation. If you want to know when it reaches maximum height, you use when the velocity equals 0. If you want to see how far horizontally it moved, you would have to have your answer for this. So let's pretend I did all this magic. Actually, I'm going to pause it and do the magic. So if I did the quadratic formula to solve this quadratic equation, you do the opposite of b, plus or minus, all that good stuff. And you get these two answers. Now, one of them makes sense for the real world and one of them doesn't. This one says negative 0.15, which is like imagining the arrow was back here in time hitting the ground. Right? So that's nonsense. I'm throwing out the negative answer. This is a real problem. So really it takes 1.71 seconds for this arrow to fly through the air and do its flight. Well, if you ask me how far implies a horizontal distance, I'm going to use this equation, 43.3 times my time it was in the air, 1.71, because your sideways distance isn't really affected by how high you are. We're pretending this is frictionless. So we got 1.71, and it flies 74.0 feet. So you can answer all sorts of questions. You just got to be careful with how far uses that equation. Hits ground is height of 0. Maximum height is when the velocity, vertical velocity is 0. I could ask acceleration. You could say what's the velocity, the vertical velocity, when it reaches the ground. You could ask what's the, if I wanted to be really cool, you could take your vertical velocity at the end and your horizontal velocity at the end and return it into a triangle and use Pythagorean Theorem to find the angle, and you could find your total angular velocity at the end. Anyway, good times. Just wanted to show you that. That should help you on this problem here as far as setting it up and breaking down the speed. Just know not to use that 103 in anything, any of the equations you write. See how like my 50 was never actually used in either of these equations? I had to break my 50 into parts. Similarly, you're going to have to break 103 feet per second. Man, that monkey's going to be flying through the air. All right, so that's it. Hope you enjoy these questions, and I will talk to you later.